Hi everyone. I'm going to be talking through the Kickstart evening material for maths. Just to introduce myself, my name is Nathan Hopwood, and I'm the director of maths here at Royds Hall. And my email address is on the screen in case you have any questions or queries that you might want answering after you've watched this video. The purpose of me talking to you this evening is to support our Year 11 students in making the best start that they can to Year 11. And what I'm going to start by looking at is how belief, hard work, and support can produce success in maths. Now, before I look at that, I just want to look at some uh, general information first. So the first thing, and a lot of people do ask this question, we follow the Edexcel exam board for GCSE maths, and the exam code for that is 1MA1. In the summer, all students sitting GCSE maths will take 3 exams, and they are paper 1, paper 2, paper 3. Paper 1 is non-calculator. Paper 2 and paper 3 are where calculators are allowed. Each exam is 1 hour and 30 minutes, and each paper is worth 80 marks, giving you a total of 240 marks. Unlike most of the GCSE subjects, maths is a tiered entry, so there's 2 levels of entry. We have foundation, whereby students can attain between a grade 1 and a grade 5, and we have the higher tier, which is looking at grades 4 to 9. Right, okay, so going and talking through this belief, hard work, and support, and how it can give us success in maths. So, looking at this belief, it's so important that we make the students believe in themselves. These are the people that are going to be sat in the exam hall in the summer, and we need to make them believe that they can achieve their absolute personal best. Now, what we can do to support them in that belief is having a culture of really positive language with students. So, for example, the use of positive language both at home and in school is so critical for students believing in themselves. Quite often we hear things like I was never really good at maths at school, or I didn't like maths. It can sometimes come across as a bit of a marmite subject. I think if we keep the language as positive as possible with maths, it helps students keep a positive impression with the subject as well. We must celebrate every success that they have. What we do as an example in school is every time students have completed their Sparks homework, which I'll talk about in a little while, we put achievement points out there. We need to celebrate all the small wins, so students build that belief and that they can keep striving towards those summer exams. Um, whilst it's really important to celebrate the successes, it's okay for students to make mistakes, because they become a learning point for students. Just assuming that you're going to get everything right first time doesn't actually help build that belief that you're going to succeed in the summer of 2024. And so having the students understand that we're going to make mistakes is absolutely fine. Um, some people might be thinking we're in year 11. What's the point in me starting to work on this now? That's absolutely not the case. We absolutely have time to close any gaps in knowledge, and myself and the maths team will be working hard over the course of year 11 to close any gaps in knowledge that students may have. Hard work. Now, this kind of goes without saying, really. That there is no shortcut where GCSEs are concerned. If students are wanting to achieve their personal best, hard work is going to get them there. Um, in order to revise maths, you have to do the maths. So some of the stuff I'll show you later on will be helpful for this. For example, before students have an assessment in maths, we give them a revision list so that they're prepared for the assessment. And that's down to students to then get onto Sparks or other revision sites and actually do some maths questions to help them get prepared. We have to constantly go back over things so that topics and knowledge is committed to long term memory. Quite often we might assume that just because we understand it in lesson, that means that we understand it later on. And that's not always the case. We need to get things into our long-term memory, and to get it into long-term memory, we have to revisit topics that have been taught in the past. Another part of maths is not just physically doing maths, but some problem solving, where we have some quite wordy questions, and students have to pick out what area of maths the question is talking about and apply that knowledge to problems. It's often a part of maths that students find quite challenging, because it's not immediately obvious what area of maths the problem might need students to rely on, and that's absolutely fine. The best way to get prepared for problems is to answer as many problems as possible, which kind of goes back to my previous point. If we do all of those three things that I've mentioned, then our students are going to know more, and ultimately they're going to remember more for when they sit that exam in the summer. The support we offer in school. So we've got an example of what an exercise book might look like. We always make sure that as teachers and as a maths team, we model to students exactly how they need to answer a particular question. So, for example, with the example you can see here, these students are working on the surface area of a sphere, and you can see how the model builds up before students then have some independent practice to really practice that skill and start committing it to long-term memory. But equally, what we will do in school as well, like I mentioned on the previous point, is that we will revisit this knowledge over the course of year 11 to ensure that it does get committed to long-term memory of the students. We also share for each unit the big picture. So this is an example of a foundation unit. This is unit 28 on circles, and it has for the students the success criteria and the components of learning for this entire unit. So for students to be successful on unit 28, they need to be able to label parts of a circle, calculate the area and circumference of a circle, etc., etc. All students are shared the big picture at the start of each unit, so they are fully aware of what knowledge they need to be secure with that unit. We often use exam questions. We sometimes call those TFIs in maths, and we do other things in lessons as well, such as low stakes quizzes, formative assessments, and then throughout the year, or later in the year, sorry, they'll be looking at a mock series with PLCs, which stands for Personal Learning Checklists. So what can we ask you guys to do at home to support students with the revision and the exam prep? After they've sat their mock exam later in the year, students will be given something called a personal learning checklist. Now, what I've done here, I've just taken the top of the one that we used last year, and they will get 3 sheets of A4 because it's 3 exams, and it will also mention the topic that's assessed on each of those questions, and it will tell the students what mark they've scored. The students can then use that to inform their revision at home, so that they're then fully prepped for their exams, because on the side of each question it has a Sparks code, so students can get onto Sparks, onto independent learning, and can then start addressing those gaps in knowledge. Significant gaps in knowledge that we pick up across year 11 and in classes. The maths team will address those in lessons, but it's always good for students to be supplementing that at home as well. We have revision guides for sale, and it's dead important that students do have a scientific calculator. We do and we can lend these, but I'd strongly suggest that students have their own, because then they're familiar with that calculator, because different scientific calculators, they've got a slightly different layout, and the appearance on the screen in this panel here does look different depending on the model of calculator that is used. Again, to support at home, you'll be aware that we do have weekly homework set on Sparks, and that is to complement and supplement what we do in lessons. So students will answer a series of questions, and an example, I've just put this one on here, with factorising 7y plus 21. And the homework that students are set on Sparks, their level is determined in the background based on all the work they've previously done on Sparks. So the questions are always pitched at a level that isn't too challenging, but isn't too straightforward. So it's the right level of challenge. Every single question, if students do need some further support with that question, they have the option to watch the video. And this is just the clip of the opening part of this video. You can see it's only 39 seconds long, and each video is very specific to the question that is being asked. So you can see here that we have factorised 7y plus 21, and in the support video, it's factorised 5y plus 30. So the examples in the support video are almost identical to the questions that students are answering. They just change the numbers. Dead important that when students are watching these videos, that like they would in lessons, they pause the video so they can catch up with writing things down, but to get that model and that example written down as well, so it helps for when they come across the question in the future or similar questions. Some other useful websites apart from Sparks. I use these quite often with classes on the run up to the exam. So that's Maths Genie. This is a website that's been put together where it's got exam questions organised by topic and it's got full work solutions. The website is there for you. An example of this, I've just pulled some area and perimeter past exam questions on there. And then on the same page, they have a full set of written solutions. So, for example, this is the written solution on question number 6 regarding the perimeter of the six-sided shape. So it's not just an answer of 36, it's got the full written solution as well. Another website that's also really useful is Corbett Maths, and this has got practice worksheets and exam style questions, again organised by topic. The website's there for you. When you do go to content, it's got, this is just part of it, from 2D shapes down to addition. The practice worksheets are what are on there as a textbook exercise, and the practice questions are the exam style questions. So here's what some exam style questions may look like. And then on the same topic, what the practice worksheet or the textbook exercise looks like. There's more of the same skill just to practice over and over again. If students are confident with the practice worksheets, then they need to be looking at exam style questions as well. And again, all solutions are on there for students to self-assess and then come to their maths teacher if they're still struggling with things. I know that that's a really quick whistle-stop tour of what we can do to support students to succeed well in maths. And if you do have any further questions, please do get in touch with me. My email address is on the screen for you now, or of course you can speak to any member of the maths team. Thanks so much.